Welcome to all of you. Today, in this very short video, uh, I want to talk regarding the VIGYANAM. So, Pandit Dindiyal Energy University is initiating a uh, workshop which is named is the VIGYANAM. We have mainly two objectives regarding the VIGYANAM. First objective is that uh, awareness regarding the research for the young science graduate. Our second objective is that to bring together all the science graduates for the research collaborations. Research collaboration means we can transfer our knowledge, right? We need to understand that facilities where it is available in which institute can I do the collaboration works. These are our two main objective of the VIGYANAM. The VIGYANAM is the workshop series that will conduct the workshop in the series of workshops. We're planning to start it is from the first week of the May. What of the rough tentative means going to be conducted our itineraries are first hands-on sessions in advanced laboratories, including the advanced simulation and modeling, right? Then we'll give the demonstrations of the advanced facilities. We have lots of Center of Excellence in Pandit Dindiyal Energy University. We'll give the demonstration hands-on experience, right? We have the 1 megawatt solar plant in PDPU itself. Then introduction with the faculties, right? And talking about the research facilities. What are the research facilities in PDEU? What are the scopes of the collaborations? We will go in details during the workshops. So now, how to join in our VIGYANAM? First thing is that here you can see here scan to register. Means we have the scan in the Google here. You can scan here. After scanning here, we can get directly register form. Then we can fill the registration here. And you can scan here in the WhatsApp group. Once you scan it, you can join in our VIGYANAM WhatsApp group. Third is that here Telegram. Once you scan here, you can get joined directly in our Telegram group. So these are the procedure that how we can register and how we can join in our this WhatsApp group and Telegram group. I am Dr. Jay Brahma from the Department of Mathematics here. Today, I'll give small glimpse that how mathematics can be applied in the science and technology, how it is useful. Okay. And my colleagues in the physics and chemistry, they will give some demonstration, maybe glimpse of this through the small video clips here. Today, basically, I am coming here to give the small glimpse of the mathematics. What are the facilities we have in the Pandit Dindiyal Energy University and what we are working presently in Pandit Dindiyal Energy University, right? Basically, here I work in the simulation and modeling, right? I do here the Petroleum Reservoir simulation and modeling. My colleagues are working in neuroscience, biomathematics. Some of my colleagues are working in oceanography. Some of my colleagues are working in optimizations. So here we have various diversity specializations. Our colleagues are working in Department of Mathematics. Today, I want to give the glimpse of the mathematics, how it is strong, how it is useful, and what are the facilities we have in our PDEU and what I am doing in my research work. Okay, here. To understand this one, what is the mathematics and how it is useful, I want to explain you here in the very short videos are here. Most of us or science graduates are talking about the independent, right? The physics guy are talking about the physics is the superior. The chemistry guys are coming we are the superior, and mathematics guy is coming, we are the superior. But it is not. There is no scope of superior, there is no scope of inferior. It should be integrated approach. Without the integrated approach, there is no benefit of the society. So I believe in the integration of physics, chemistry, and mathematics, all the science. Then only we can get the benefit of our society. Otherwise, independently, it is not possible to have our society, maybe in terms of industry, maybe in terms of our different type of scopes. So I believe the integrated approach. Now come up to the mathematics background here. Most of the people are not fall in love in the mathematics because it may be our fault of the mathematics professors and faculties. We are not able to attract the students towards the mathematics. Right? They feel that mathematics is too much ugly that no one is fall in love in the mathematics. But today, I'll give you a small glimpse here how it is beautiful, how it is strong, how it is powerful. Let us talk about here mathematical modeling and simulation. Right. If I talk about the mathematical modeling and simulation. Mathematical modeling and simulations. This type of modeling and simulations, we are going to give the hands-on experience in the VIGYANAM series of workshop. That's why I request all the mathematics guy or any science graduate, those who are interested in modeling and simulation, you please register in our VIGYANAM workshop series. You can get all this hands-on experience, right, in our PDEU. Mathematical modeling and simulations. See, mathematical modeling and simulation alone cannot be applicable for the society. We need the help of either physics, chemistry, or any sciences. Look here, how we can model mathematics, how we can do the simulation here. Without integration, it should be integrated study. It should be integrated study. Then only we can get some output for the society. For example, what I'm trying to explain here, look here. How we can do the mathematical modeling and simulation. Look here, force is called, this is called the physical model. This is called the physical model. Physical model. Without the help of the physical science, I cannot understand the physical model. After physical model is complete, then I have to come the mathematical model. Mathematical model. I'll come the mathematical model. After it is coming, we'll go here for simulation. If mathematical model is clear, then I have to do the simulation part here. We have to do the simulation here. This type of hands-on experiment is going to be performed in our VIGYANAM series of workshop. There is no superior, there is no inferior. We are going to discuss how integrate. I have mentioned here physical model, mathematical model, and simulations. Then only we can get some outputs here. And today's video also, I'm going to do two simulations, how it is working here. Look here, how physical model can be done. What is the physical model? If I want to do the physical model, I should understand the system. If I want to do the physical model, I should understand the system. What is the system? The system may be electrical system. It may be a biological system, right? It may be a reservoir system. For system, we need to understand the science behind it. For example, let us talk, I'm planning to make a physical model of a reservoir, suppose petroleum reservoir. If I want to talk the petroleum reservoir. I want to make the physical model of petroleum reservoir. How can I? How can I make the physical model? First, I should understand. I should understand the reservoir system. First, I should understand the reservoir system. Now, how can I understand the reservoir system? To understand the reservoir system, I have to study that reservoir system. What are the parameters, right? What are the parameters that control the reservoir system? Here, I want to speak it very clearly that in the physical model, if I talk about this one, it may be depend upon porosity. It is depend on porosity. It is depend on permeability. It is depend on viscosity, right? It is depend on pressure, when fluid pressure. It is depend on fluid pressure. These are the petroleum systems we have. It is depend on fluid pressure also, right? These are the parameters. Now, if I want to make a physical model, I should understand the role of the porosity. I should understand the role of the permeability. I should understand the role of the viscosity. I should understand the role of fluid pressure. Or there are a number of parameters which involve to describe the petroleum system. It means that the mathematics persons cannot do alone if I don't have all these parameters. Means I should understand the science behind it inside the petroleum reservoir. Then only I can identify the roles of all the parameters. Now, if I have understood the role of the porosity, if I have understood the role of the permeability, if I have understood the role of viscosity, if I have understood the role of the fluid pressure, after the understanding it, I'll go in the next step. What is the next step? Next step is mathematical modeling. What is the mathematical modeling? The modeling will become in the form of partial differential equation. Partial differential equation. Most of the cases in the reservoir study, we can get in the partial differential equation, PDE. Now, this partial differential equation is called in mathematical model, this is called a formulation. This is called the formulation of mathematical model, right? Formulation of model, which is mathematical model. Now, how I can form it? I can form it if I can understand the role of the porosity, if I can understand the role of the permeability, if I do understand the role of the viscosity, what type of fluid, Newtonian, non-Newtonian, everything, if I do the understand it, then only I can form the mathematical model, which is formed in the form of partial differential equation. So from the physical model, I should know the science behind in the reservoir system. Then only I can form one mathematical model. This model will become in terms of partial differential equation. So this is called a mathematical model. Have you seen here? I took the help of physics guy because to understand the science, I should know the physics and chemistry behind it. Without chemistry, without physics, we are not able to do that. And physics and chemistry is not mean that there is no use of the mathematics guy. Without the mathematics guy, we are not able to form all these formulations of mathematical model. So now somebody may take that, why we require the mathematical model? It is very powerful. Why it is? Without going inside the petroleum reservoir, we can predict it. We can speak about the pressure distribution. We can speak about the fluid flow through the porous media, how many times it required, what is the amount, what is the volume. We can speak on the basis of mathematical model. This is called a prediction. It means that the role of the physical science, the role of the chemical science is essential to understand the petroleum reservoir. Then only we can write a mathematical model which is in the form of partial differential equations. So we have formed the equations. Now come up here. After coming here, we have to do the simulation. Most of the cases we confuse that what is the mathematical model. Very systematic single line answer is that it is the representation of the system in the form of equations. Mathematical model, it is the representation of the system. What is the system? It may be neural system in human body. It may be biological system. It may be electric system. It may be reservoir system. It may be power plant system. It may be refinery system. Means system has to be represented in the form of equations. This is called the mathematical model. It means it is representations of the system. Now, what is about the simulations? Now, simulation required a different type of methods to solve our mathematical model, and we have to impose the conditions. We have to, condition means what is the initial value, what is the boundary values, and what situation, what would be the initial and boundary condition. It means we have to impose the condition. We have to impose the condition that this is the conditions as part of this situation. Then only we can get the appropriate solutions. Basically, here we use the numerical methods. We use the numerical methods. Right? We apply here numerical methods now. There may be lots of numerical methods. It may be finite elements method, finite difference method, finite volumes method. We can apply any of the methods along with the suitable initial and boundary conditions. Then after doing the simulations, we can get here output. This output is how it is coming. The output is coming. How it is coming? We have constructed physical model, right? How it can be? We have to study science behind it. We have developed the mathematical model. How it is developed? By understanding the parameters of the system. Then we represent in the form of equations. Now we have to solve it. How to solve it? By using the numerical technique and numerical methods. Simulation means we have to solve using the differential means numerical techniques with the suitable conditions, right? We can get the output. These are the very small, very basic classifications of physical model, mathematical model, and simulation. I am just giving the very small glimpse of our upcoming VIGYANAM workshop series. Once you come in our series in VIGYANAM programs, you can get in details explanation along with hands-on experiment. Here today, I want to show you very small to experiment how we can distribute the pressure in the petroleum reservoir using the mathematical modeling and simulations. Be careful here. Most of the mathematics guy are feel that simulation is not the word of the mathematics. Don't feel like this. We are all science, right? We're talking about a scientific graduate. We're trying to integrate physics, chemistry, mathematics, and any of the science. Here, two experiment I want to give here in this today's videos. One is that if I have petroleum reservoir, right? Suppose in the subsurface means below the surface. Suppose we have in the 3 kilometer depth we have petroleum reservoir, right? Now, after getting this information, there is a petroleum in the subsurface. For example, here, for example, see, this is the surface, earth surface, right? This is the, suppose this is the earth surface, right? This is the earth surface. There may be hills, right? There may be trees, right? These are our earth surface, right? These are our earth surface. Suppose for some depth here we have petroleum reservoir here, right? Suppose this is the petroleum reservoir. This is the petroleum reservoir, right? This is the petroleum reservoir, right? Suppose the depth is around, suppose maybe 4 km depth, we have the petroleum reservoir. Once we can get the petroleum reservoir, so we'll do the drilling here, right? We'll do the drilling here. After drilling, we can produce here the hydrocarbons, right? After taking out from the hydrocarbon here, the reservoir pressure will drop, right? The reservoir pressure will drop. Once we start here production, right? Once we start the production, right? The pressure of the reservoir will be reduced. Pressure of the reservoir will be reduced. Now, the mathematician, with the help of other aligned subjects, we can develop one model that once we got the informations with the scientific study, there is a petroleum reservoir, there is a petroleum, then we start the production there. Now, if the pressure is dropped, the hydrocarbon is not coming automatically on the surface. Then we have to use some our artificial pressure. So to chuck this, and chucking you have to use, then we can get the hydrocarbon. Can we develop one model? Can we develop one physical model, mathematical model, and simulation that how many years is required that we have to apply the extra sucker pump rod to pump out the hydrocarbon from the reservoir? Once we started here hydrocarbon productions, the reservoir is decreased, means pressure is decreased here. It means it cannot push up the hydrocarbon automatically on the surface. So we need to apply our sucker rod pump. This is called SRP, sucker rod pump. Now, can I develop one model? Can I develop one model? How many years required, and what is the function of time? What is the relationship between pressure and time? How many years after production the pressure will be decreased in such a way that we have to apply our SRP? So we can develop one model. After 10 years, after 14 years, after 15 years, what is the pressure distribution in the reservoir, right? We can develop one model. What is the pressure distribution in the reservoir after 20 years, after 40 years, after 30 years? So we can develop one model. So I have developed one model here. I'll show you. Second model is that suppose I have, this is W1. This is called a production well, W well. And suppose I have here another well, W2. We are producing hydrocarbon from here, and also we are producing hydrocarbon from here. The distance may be 150 kilometers between it. Now, from this well to from this well, I can also find out the pressure distribution, or I can find out the property of the petrophysical parameters. What is the variation of the petrophysical parameters from this well to another well? Can you model it? Today, in this video, I will show two models. One is after the productions, due to the productions, the reservoir pressure is reduced. How it is reduced? With time. Second is that what is the petrophysical parameter distribution from one production well to the another production well, from this production well and up to another production well? How it is variation from here? This is another production well. From here, how to set? Now, how we can apply now mathematics here? What are the differential equations? What are the physical significance? How it can model it? Just look here. I want to show here very small here program that how we can run this program here. Just look here. I have here. Oh, just we require some time because the system is hanging here. MATLAB is on here. It requires some time. Let's keep it small time. The MATLAB is showing, I don't know why it is showing like this. Yes, our VIGYANAM here, and there is the VIGYANAM. We have list down number of hands-on experiments, but today I'll see two small glimpses in mathematical modeling and simulations, hands-on, how you can feel in that case here. I don't know why this MATLAB is not working here. So the system is hanged because the modeling is too much here high, is that sometimes it becomes lots of time. It is showing here. Let's keep a few time here. Give me a few time. It has become hang. MATLAB is not responding. Okay, let us stop here right now. We have here mainly two models. One model I will discuss that how pressure is distributed in the reservoir and how the pressure is decreased along with the time. If time is increased, how pressure is decreased. I'll show it. Second is that how all these parameters are changing along with the distance. So I will give these two glimpses to all of you. Sorry here. Let me open the MATLAB now. Because the programs whatever I have made it is very huge program is loaded there, so it's taking some time. Just bear with me. Yes, and now look here. So on the screen, you have seen here MATLAB here. The program I have made already here. Once you come in our institute, what we'll do that we'll do the hands-on how we can develop all this model. Maybe in the physics, maybe in chemistry, they are going to demonstrate you. We have so highly sophisticated instrument in our PDE. Simultaneously, we have very strong, powerful simulation lab here, so we can do the simulation here. Just look here. What my discussion was that how we can model, maybe physical model, maybe in the mathematical model, maybe in the different type of simulations and modeling. Look here. In that purpose, let me open our MATLAB. Sorry, it has become very slow due to some reason here. Just bear me. MATLAB is opening here because the MATLAB is very highly very highly loaded here, because the simulation sometimes it take 2 days or 3 days or 6 days. But today I'm showing a very simple model where we can get, and within the minutes we can get the run here. But I have here very loaded system. Please bear with me. The MATLAB is running here. Just on the screen, you can see I just on the MATLAB here. You can see here. It required lots of time because very high computing is taking place here in the MATLAB. Just bear with me here. Just give me a few minutes here. So just MATLAB is going on here. So MATLAB requires some time here. It is opening here. On the screen, you can see the MATLAB. It is R2017A version. Yes, now here MATLAB is open here, but it requires some more time here. It okay has some more time, so bear with me. So we require some more time. Because the simulation is too much high there. It is too much high there. Sometimes it requires lots of here. Means become very critical sometime. So bear with me. Here. If I run it here. So see here. See, I have a minute here. Now let us try to run our simulations. So what we had discussed is that we have two models. One is how the pressure is function of time. With the time increasing, how pressure is decreasing here. Look here, just listen in my program now here. I am going to run here. It requires some time. See, look here. Now program is run here. Program is running here. Now figure will come now automatic here. Look here. Just figure is coming. Just you have seen on the screen, right? See, I have put here scale. Scale is from the left to right. The pressure is increasing here, right? From blue to red. Now look here. This is the P1 production one, right? So in the first 14 days, there was so high pressure. Next 35 days, the pressure is decreased. Next 70 days, again pressure is decreased. Next 140 days, we get the lowest pressure. Have you seen here how the model can be created by using the mathematical model and simulations? What we did here, we took the help of other branch of the sciences. Then we develop the physical model. Then we develop the mathematical model and then do the simulations. After simulations, we found that the pressure is decreasing with time. How beautiful it is, right? Today, I'm not showing the details hands-on. I'm just giving the glimpse of this one. In the PDP, once you visit here in our VIGYANAM workshop series, we're trying to demonstrate all this type of hands-on simulation and modeling. In physics and chemistry, also we're doing in the hands-on experiment in the highly sophisticated instruments. Now look here, again come up. Let us try to run my another program. This is my another simulation. Look here, look here. How beautiful it is, right? From wall number 1 to wall number 2, how the petrophysical properties are changing. This is the color code, right? Look here, look here. Have you seen here? The properties of the petrophysical parameters are changing once you move from one wall to another wall. How it is changed? Can you imagine that? How powerful is mathematics? How powerful is mathematics that we can nicely represent that how the petrophysical parameters, how the reservoir system is working, how we can discuss the reservoir system, right? It means that you mean that we need to do the integrations of all the science. That's why we're planning this VIGYANAM, that how we can give the awareness of our research orientation mind, how we can bring up all the science graduates to work together, how we can transfer our knowledge to each other for the benefit of the society. I hope you have got the idea of our VIGYANAM series, that how we are going to organize it and why we are going to organize it. So thank you very much. Today I have stopped my video here. I hope all of you have got this informations that how we are planning to do for the benefit of the upcoming graduate students. I request all of you, please do the registrations and join the WhatsApp and Telegram group. If we have already given in the flyer in the poster here. Please register here, scan to register and join us in the Telegram and WhatsApp group. Thank you very much. I'm waiting for your registrations. Right. I'll be grateful once you come here, join with us and help us to popularize the science for the society. Thank you very much.